Welcome to this deep dive into access modifiers and encapsulation in C# for Unity, designed specifically for beginner programmers and game developers. This comprehensive guide will equip you with the foundational knowledge to write cleaner, more robust code for your projects.
Today, we'll explore what these fundamental concepts are and why they are crucial for writing robust and maintainable code in your Unity projects. Understanding these principles is key to developing scalable and error-resistant applications. This video will guide you step by step through the different types of access modifiers, explain encapsulation in detail, and provide practical demonstrations in both Visual Studio and Unity 3D. We'll show you how these concepts are applied in real-world game development scenarios. We'll also share best practices and helpful tips to enhance your coding efficiency and project organization. These insights will help you avoid common pitfalls and write more professional-grade code. First, let's define what access modifiers are in C#. These keywords are fundamental to controlling how different parts of your code interact with each other. Access modifiers are keywords that control the accessibility or visibility of class members such as variables and methods. They dictate which parts of your program can see and interact with specific elements within your classes. They essentially define from where these members can be accessed, acting as gatekeepers for your code. This control is vital for maintaining the integrity and structure of your software. The primary purpose of access modifiers is to support encapsulation by hiding internal implementation details. By doing so, they protect the internal state of an object from external, unauthorized manipulation. They also aid in code organization by defining clear interfaces for interaction and prevent unintended modifications to your program state. This leads to more predictable and easier to debug code. Now, let's delve into the specific types of access modifiers available in C#. Each modifier serves a distinct purpose in managing code visibility and access. The public modifier makes a member accessible from anywhere, meaning any other class or script can access and modify it. This is the least restrictive access level, offering broad visibility. This is ideal for methods or variables that need to be widely available across your application, such as an object's position or a function to initiate an action. It's often used for the public interface of a class. In Unity, a public variable in a script attached to a game object can be directly modified from the inspector panel during runtime. This provides a convenient way for designers and developers to tweak values without altering code. Next, the private modifier restricts access to only within the same class. This is the most restrictive access level, ensuring that members are only visible and usable internally. These are internal variables and methods that should not be accessed or modified from outside their defining class. They are crucial for maintaining the internal state and logic of an object, hidden from external interference. Attempting to access a private variable from another class will result in a compilation error, as demonstrated here in Visual Studio. This strict enforcement prevents accidental or unauthorized data manipulation. The protected modifier allows access within the same class and by derived classes, also known as subclasses. This is particularly useful in inheritance hierarchies. This is useful for base class members that need to be accessible to subclasses but hidden from other unrelated classes. It allows for shared functionality among related classes while maintaining a degree of encapsulation. Here, we see a base class with a protected variable and a derived class successfully accessing it. This illustrates how protected members facilitate controlled inheritance. The internal modifier makes a member accessible only within the same assembly or project. This means it's visible throughout the current project, but not to other projects that might reference it. It's suitable for application-wide functionality that should not be exposed externally to other assemblies. This helps in building modular applications where certain components are only for internal use. Observe how an internal member in one project cannot be accessed from another separate class library project within the same solution. This clearly demonstrates its assembly-level scope. Combining protected and internal gives us protected internal, which means accessible within the same assembly or from a derived class in another assembly. This offers a flexible access level for complex project structures. Finally, private protected, introduced in C# 7.2,
is accessible only within the same assembly and within the same class or a derived class. This is the most specific and restrictive combination of access modifiers. This modifier offers a more restrictive scope than protected internal, ensuring tighter control over member access. It's ideal for scenarios where you want to limit access to a very specific set of related classes within the same project. Now, let's explore encapsulation in more detail. Encapsulation is a core principle of object-oriented programming that works hand-in-hand with access modifiers. Encapsulation is the practice of bundling data and the methods that operate on that data into a single unit, typically a class. This creates a self-contained entity that manages its own state and behavior. Crucially, it involves hiding the internal implementation details from the outside world. This means external code interacts with an object through a well-defined interface, without needing to know its inner workings. Encapsulation is primarily achieved through the judicious use of access modifiers, especially private. By making fields private, we prevent direct external access, forcing interaction through controlled methods or properties. The benefits of encapsulation are numerous, starting with data hiding, which prevents unauthorized access to sensitive information. This protects the integrity of your object state. It also improves code maintainability, making it easier to modify and update code without affecting other parts of the program. Changes to internal logic don't ripple through the entire code base. Encapsulation offers flexibility, allowing internal implementation changes without impacting external code, and significantly increases security. This means you can refactor your internal code without breaking external dependencies. Think of encapsulation like a medicine capsule, where the active ingredients are contained and protected, or a car engine hidden under the hood. The user interacts with the car's controls, not its complex internal machinery. A powerful way to implement encapsulation in C# is by using properties. Properties provide a controlled and flexible interface for accessing and modifying private fields. Properties are class members that provide a flexible mechanism to read, write, or compute the value of a private field. They act as smart fields, allowing you to add logic during access. They consist of get and set accessors, allowing controlled interaction with the underlying private data. The get accessor retrieves the value, while the set accessor assigns it, often with validation. Consider this example, a private _speed field and a public speed property. This setup is a common pattern for encapsulating data. The _speed field is private, ensuring it cannot be directly accessed from outside the class. This protects its raw value from uncontrolled external changes. The speed property, however, provides controlled access. Its get accessor returns the value of _speed. This allows external code to read the speed without directly touching the private field. The set accessor allows setting the value of _speed only after performing validation, such as ensuring the value is non-negative. This is where you can enforce business rules and maintain data integrity. In Unity, we can create a script with a private variable and a public property to control its access. This allows us to expose controlled data to the Unity editor while maintaining encapsulation. This demonstration shows how the property can be used to control values, preventing invalid inputs like negative speed. This ensures that your game logic always operates with valid data, preventing bugs and unexpected behavior. For simpler scenarios, C# offers automatic properties, where no additional logic is needed in the get and set accessors. These provide a concise syntax for common property patterns. Here, health is an auto-implemented property with a public getter and a private setter, allowing external reading but internal modification. This is useful when you want to control how a value is set internally, but allow it to be read externally. Let's summarize some best practices and helpful tips for using access modifiers and encapsulation. Adhering to these guidelines will significantly improve your code quality. Always start by declaring variables and methods with the most restrictive access modifier, typically private. This follows the principle of least privilege, minimizing potential points of failure.
Then, increase accessibility only when absolutely necessary, following the principle of least privilege. Each increase in accessibility should be a conscious decision, justified by the design requirements.
Use properties for controlled access to your data, allowing for validation and other logic before values are set. This is your primary tool for enforcing encapsulation and data integrity. Minimize the use of public variables to reduce the risk of unintended modifications and improve overall code maintainability. Direct public field access bypasses any validation or logic you might want to implement. In Unity, to expose private variables in the inspector for editing while keeping them encapsulated, use the serialized field attribute. This is a powerful Unity-specific feature for game development. This allows you to tweak values in the editor without breaking encapsulation principles. The variable remains private in your code, but Unity's inspector can still interact with it, offering the best of both worlds. Finally, always group related variables and methods within classes to improve code structure and readability. Well-organized classes are easier to understand, maintain, and extend. In summary, we've covered the essential concepts of access modifiers and encapsulation in C# for Unity. These are foundational pillars for writing professional-grade software.
You now understand what public, private, protected internal, and private protected mean and how they control member visibility. Each modifier plays a specific role in defining access boundaries.
We also explored encapsulation, its benefits, and how properties are a powerful tool for achieving it. Encapsulation is key to creating modular, maintainable, and secure code. Mastering these concepts is vital for writing robust, maintainable, and secure code in your Unity game development journey. They will empower you to build complex and reliable game systems. We encourage you to continue exploring C# and Unity documentation for more advanced topics and to deepen your understanding. Practice these concepts in your own projects to solidify your learning. Thank you for watching, and happy coding. We hope this guide has provided a solid foundation for your journey into C# and Unity development.